Well, everybody, we've been talking about proportional equations and graphs and tables, and that's what this one is. You can see, remember the one assignment where we divided. It was called proportional or non-proportional, right? You would divide 8 divided by 1, 16 divided by 2, 24 divided by 3, and there was a column out here you had to put those answers. And in this case, they would all give us 8. And you would say, yes, it's proportional. Equations all look like this if they're proportional. There's no number out here on the end. On the graph, there's straight lines through the origin. Then in the next assignment, you had to write these equations for a table and for a graph and for a word problem. And we called this number here the constant of proportionality, called the unit rate or rate of change. So that kind of summarizes proportional. We're going to start talking about non-proportional now. So we've already graphed these kind. We've made these input-output tables and graphed them. We're going to start talking now more about some of the theory. But to show you the difference, it's a straight line that does not go through the origin. If you divide y divided by x, look, 14 divided by 1, 14. 18 divided by 2, 9. 22 divided by 3 doesn't even divide evenly. You get 3 different numbers. We would know this is non-proportional by looking at the table. We can tell it's non-proportional looking at the graph. See, it doesn't go through the origin. You can tell it's non-proportional looking at the equation. It has this number on the end. See that number 10? It's right where it hits the y-axis. So that's more down the road. Okay, we're going to start talking about this number right here. Now, if it's non-proportional, you can't call it constant of proportionality. We call it the slope. It's sometimes also called the rate of change. Same thing. So our job today is to find the slope if we're given a graph. Okay, find the slope from a graph. But we will do this soon. Find slope given an equation. But this is our job today. Find the slope from a line on a graph. So, couple quick things. If the line is falling down from left to right, the slope is negative. Okay, and I know people say, yeah, but it's going up. But from left to right, the direction that we read, it's falling down. Horizontal lines have zero slope. If it's a vertical line, the slope is actually called undefined. To answer as a word, more about that later. Okay, we really have to cover this one thing at a time. If the line goes up from left to right, the slope must be positive. Okay, so if you're wondering, yeah, but that's all well and good, but what are we actually doing? Well, here we go. We are going to find the slope of a line. Now remember, slope is this m, and I think I wrote that on top of the assignment. I did. If you're wondering what in the world is m equals, equations that are in this form, m is the slope. Again, we've already graphed those, but just more about y-intercept another day. Let's just concentrate on our skill we need right now. We have to give the slope of this line. So if you go back to what I was just showing you, since the line is falling down, your answer has to have a negative sign. Okay, now slope is usually considered rise over run. So it's going to be a fraction. That means the vertical change is over the horizontal change. And I'll show you what that looks like when we start to count some blocks. But what I'm talking about is at the bottom of the paper. Okay, our answer is going to be a fraction. And I'll show you what this means. This is vertical change over horizontal change, same as rise over run. So what we really do is we try to travel from this block to, or that point to that point. So I normally will go up or down first. And I'm just going to drop down to where I'm on the same level as this point. So that's why I stopped there. And I'm going to connect over to here. I'm just forming a triangle between the 2 points. Now you can go above the line if you want. I'm just going to stay below the line. Now I'm going to count. How many blocks is this? 1, 2, 3, 4, 5, 6, 7. That is a vertical change of 7. That's rise. Run, 1, 2, 3, 4, 5, 6, 7, 8, 9. My slope is rise over run. 7 over 9. Now remember, we said it's falling down. Make sure you put a negative sign on your answer. It could be with the 7, with the 9, or with the fraction bar. That doesn't matter. Okay, so let's try a couple more. Same, I'm going to go from the point on the left to the point on the right. So I just try to find that corner. See that corner right there? That's the same height as this one. And I just form a step. And now I count. The slope, this number's telling us what the line does. It says it drops down 7, then goes over 9. See, drops down 7, then goes over 9. What's this line doing? Well, it looks like it's going up 4 and over 4, 5, 6. Rise over run. Don't write these upside down. Now I could divide out the 2's there and simplify this, but that answer is fine. That is the slope. Okay, we'll do 2 more together. Now have you try the last few. Okay, so let's see. I want you thinking ahead now. What would you do first? Well, let's form that triangle. Again, don't ever go past the points. It has to look just like that. 1, 2, 3, 4. 1, 2, 3, 4, 5. See, I'm just counting these little blocks here. Now, my answer is missing something. You know what it is? The line is falling down. Negative slope. You always have to look for that. See these 2 on the left falling down? Negative signs. Look at our first one up here on this side. Going up. Positive. Okay, 1 more together. So this one looks like it only drops down 1, so I'm on the same level as the other point. Let's count our blocks. It looks like a 1 and a 1, 2, 3, 4. Rise 1, run 4, falling down, negative. Don't write that as 4 over 1, everybody. Remember, this is on the bottom of the paper. And I'll scan these notes here, this page. Rise over run. All right, you try these 4, and then we'll stop. I know this video is a little long. They always seem to get that way, don't they? Okay, well, I'm assuming you might have tried these, so here we go. Up 2, over 1, 2, 3, 4, 5. Rise, run, 2 over 5. So it's going up, it stays positive. Done with that one. Here, this one, all the way to the bottom we have to go. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 6 over 4. Wait, it's negative. And again, I'll divide out the even numbers there and simplify a little bit. Don't make these mixed numbers or decimals or anything, please. Just leave them fractions. Last 2, let's see how you did. Looks like 1, 2, 3, 4, 5. And that's a 1. Rise over run. Looks like that one is falling down. So that's going to be a negative. And if it divides evenly, you can divide it. You don't have to, though, for me. Unless the directions were to say simplify. But this one, if you weren't sure about this one, well, let's go back to that what I showed you earlier. A vertical line, the slope is undefined. And the reason is, it does rise 3, but it runs 0. If you divide that in a calculator, it's going to tell you error. You cannot divide by 0. Again, more about that when we do some other things. But that's really the answer. Okay, if you have any questions about the assignment, I'll just quickly show you what it looks like. It's just these. Exactly that. Let me know. Otherwise, good luck on your assignment.